I won't take quite as long as on this one. Okay, now we're going to do volume right here. Volume is basically how much stuff you can put into here. Okay, how much water you can put in, or how much, how much. I don't know a better word. Just how much stuff. Okay, you can fit inside of here. Okay, it's the space that's available inside of these solids right here. So really, we're not talking about a solid. It's kind of like an open, right? We can actually put stuff in there. It's how much stuff we'll take out, we can put in there. Let's take a look at this, the volume. Now here, let me give you a little basic equation. The volume is the area of the base times the height. Actually, sometimes volume is a little easier than surface area. Okay, so the volume is the area of the base times the height. Check this out. That's exactly what it says right here, isn't it? I want to find the area of the base and just multiply it by the height. That's the volume. Really simple. Same thing with the cylinder. All right, you don't even have to memorize this thing right here. Just memorize this, area of the base times the height. Because what kind of figure is the base of a cylinder?
Circle.
It's a circle. So look, that's where they got pi r squared, isn't it? Times the height, which is h. Do you really have to memorize this? No, just memorize the volume is the area of the base times the height. If you can memorize that, then you can do any of these figures. Okay, here's a hexagon again. Okay, hexagonal prism. If I want to find the area of this, or the volume, how would you find the volume? Just find the area of the base, and then do what? Multiply it by the height. Do you need to learn a specific equation? No. Now you got to know how to find the area of a hexagon, which you probably don't know how to do right now. We'll do that later on. All right. Now look at the difference between a regular pyramid and a cone right here. It's the same thing, except what did they introduce? A 1/3. So a cone or a pyramid is exactly 1/3 of what it would be if it was a prism. Okay, if the base is the same, it's 1/3 of it. That's all it is. So this is a prism. This is volume of a prism or a cylinder. Volume of a pyramid or cone is just 1/3 the area of the base times the height. I know I'm throwing a lot of stuff out at you, but go back on YouTube and it might come back to you, all right? Because you might lose some stuff here. This right here is a pyramid and cone.
Okay.
Because look, it takes up less room, doesn't it? If I had, let's see if I have, I don't know if these fit perfectly or not. All right, what did I do with my cone? There it is. Of course, it's at the bottom. There it is. And they're not the same height, but that's okay. Watch. If let's say this fit perfectly inside of this cylinder. Let's just pretend, okay? It's a little bit taller, but let's pretend this fits perfectly inside of this. Everybody with me? That cone is not going to take up all the volume here. It's going to take up how much of this? 1/3 of it, right? 1/3 of it, okay? It only takes up 1/3. That means how much empty space is there compared to the original cylinder? 2/3, exactly. Make sense? So this only takes up 1/3 of this cylinder right here, providing they're the same height. Okay, you have to assume that. Same base, same height. This takes up 1/3 of this thing right here, okay? And that's what that is. So this is pyramid and cone. This is prism and cylinder. You may want to jot those down. I just don't have enough room to write that stuff down. Let's, so we talked about that. We talked about that. Now let's go to a sphere. A sphere, I'm not going to go through. Basically, a sphere is this. Let's pretend, watch this. Let's pretend that this sphere fits perfectly inside. And this one looks like it does. If I was to open this thing up, this would fit right inside of it. Now, pretend this sphere is inside the cylinder. Is it taking up the whole entire cylinder?
No.
No. There's a lot left over, isn't there? But what do you think? Does this take up more than that cone would or less?
More.
Probably takes up more, doesn't it? This looks like it takes up a lot more space than what the cone does. It actually takes up twice as much space as the cone, which means it takes up not 1/3 of this cylinder, but 2/3 of the cylinder. So let's see if I can jot this down. So watch. The volume, watch. I didn't do this in the other class, but I'll do it with you guys. Watch. So the volume is actually 2/3 of the cylinder. And what's a cylinder? It's pi r squared h. Now let's talk about the h for a second. In relationship to this sphere, what is the height in relationship to the radius of this sphere? Well, the radius would go from here to here, right? So the height would be twice as much. That's right. So if the radius goes from here to here, you follow me? What is the height of this sphere? It would be twice the radius, wouldn't it? Okay, you follow me? So watch what I'm going to do. I'm going to put times the height. Instead of height, I'm going to put 2 times the radius. Now watch. This is how we get this crazy equation right here. I just want to show you where it comes from. 2/3 times 2 is what? 4/3, right? It's got a pi. Look at my r's. I got an r squared and an r. What's r squared times r? R cubed. Check it out. All right? It still works, but it's 2/3 of the cylinder. All right? This is the volume of a cylinder. H was 2r. You get it? And 2/3 times this is actually 4/3 pi r cubed. That's how they get that crazy equation right there, that formula for the volume of a sphere. It's kind of cool to see, isn't it? Where it comes from.
Sure.
Right? Yeah. Okay? It's way better than just learning it and saying, oh, there it is. I don't know where it came from. Okay, I kind of like that a little bit better. All right, enough of that. What's the assignment? It's section 17, pages 71 and 72, 18 to 29. Okay, there it is. Right there.
Oh, yeah.
And that's all I got for you.
That's all?
That's it. I didn't? Okay, I forgot.
Nope, never mind.
It was 18 to 59. I'm sorry.
That sounds more like
Just kidding. Nah, I'm just kidding. All right, everybody say bye. Have a good weekend.
Bye.